All right. Finally ready. Let's get started. So we going over the homework. I'm going to start with question 8 on the homework. And question 8, we want to factor this out. So x to the fourth plus 3x cubed minus 26x squared minus 48x plus 160. I want to factor this out. And since all my coefficients are integers, that means the rational root theorem works. So that means all my possible zeros are going to be plus or minus factors of 160. So I have 1 is going to work, 2 is going to work, 3 doesn't work, 4 works, 5 is going to work, 6 doesn't work, 7 doesn't work, 8 works, 9 is not going to work, 10 works, 11 doesn't work, 12, does 12 work? No. 12 doesn't work, 14 does not work, 15 works, right? No, 15 doesn't work. Doesn't. But 16 does work with 10. With 8, it's going to be 20. With 5, it's going to be 32. With 4, it's going to be 40. With 2, it's 80. And then 160. So these are all my possible zeros. And I'm going to have to go and try them and see which one works. So I'm going to set up my synthetic division. I have my coefficients of 1, 3, negative 26, negative 48, and 160. And I'll start with 1. Like, we're not trying to be mean with you guys, so we're not going to make it like 16 is one that is going to end up working first. It's usually going to be the first few that's going to end up working. So kind of go in the order of positive 1, negative 1, positive 2, negative 2, positive 4, negative 4. We're gonna try our best to make it the first few that work. So don't randomly guess or start in the middle or something. It's gonna be the first few that work. I think the ones on the homework are a lot worse than the ones on the first. So I'm gonna start with 1, drop down to 1. 1 times 1 is 1, plus 3 is 4. 4 and negative 26 is negative 22. Negative 22 and negative 48, that's gonna be negative 60. And that ends up giving me positive 100. That's not going to work. So from there, I'll go to negative 1. Same thing, drop to 1. Negative 1 times 1 is negative 1. Plus 3 is 2. Negative 1 times 2 is negative 2. Plus negative 26 is negative 28. Then positive 28 plus 48, that's 76, negative 76. And I can tell whatever that's going to be, 76. It's not going to end up working. I can skip it and keep going. So then I'll go to 2. Same thing, drop down to 1. 2 times 1 is 2, plus 3 is 5. 2 times 5 is 10, plus negative 26 is negative 16. Negative 32 and 48 is negative 80. Then negative 160 and 60 is going to give me 0. So my first factor that works is going to be 2. So that means if I factor out that 2 I just found, my current factored form is x minus 2 that I got from the one that worked, times my quotient right there, which is x cubed plus 5x squared minus 16x minus 8. Everyone with me so far? Are we okay? All right. And then from there, I need to factor out x cubed again. $16 times 5 is 80, right? You can actually do factor by grouping for that second part to do it faster. I'm not going to do it that way just because this unit's about synthetic division. I don't think it works that way. But you could, it looks like you could do synthetic division here to factor, I mean, not synthetic, sorry, factor by grouping there to make it work. But we're not going to do that. So my coefficients are 1, 5, negative 16, and negative 80. If I look back at my previous list, I already tried 1 and negative 1, and neither of those worked. So instead of trying those again, because I know they're not going to work again, I can just start from the 2 that worked before. Then drop down to 1. 2 times 1 is 2, plus 5 is 7. 2 times 7 is 14, plus negative 16 is negative 2. Then negative 4 and negative 80 is negative 84. That's not 0. So 2 doesn't work. Let's go ahead and try negative 2. Same thing, drop down to 1. Negative 2 times 1 is negative 2. Negative 2 plus 5 is negative 7. 14 and negative 16 is negative 2. 4, negative 80, negative 76. All right, that didn't work either. Let's go on to 4. Drop down to 1. 4 times 1 is 4, plus 5 is 9. 36 and negative 16 is 20. 4 times 20 is 80, with negative 80 is 3. Everyone with me? Are we okay? So 4 works. So my previous factor of x minus 2, I'm going to bring that down. My new factor of x minus 4 times x squared plus 9x plus 20. So that's my current factor form that I got from synthetic division. And then once you get to a quadratic, that's when you stop doing synthetic division. Because synthetic division is kind of like your last resort. It's like the last thing you ever want to do. It's a pain. So once you get down to your quadratic, that's when you want to either factor, any other way you can, or complete the square or whatever. And in this case, I can just factor x squared plus 9x plus 20 factors to x plus 4, x plus 5. And that's your factor form. If you want your zeros is going to be the set of 2, 4, negative 4, negative 5. Any questions about that? Does that make sense? Good. Go ahead.
So for each of the sets,
Like this? It depends on the problem. Honestly, I forgot what this problem asked. They said just factored. If it said solve for the x's, so I just did both. Like this is the factor form, right? And then this right here is your all your roots, all your zeros. All right. Let's go on to 26. So 26, a container in the shape of a rectangular prism is expected to have a width that is 5 feet less than the length, a height that's 3 feet less than twice the length, and a volume of 154 cubic feet. We want to find the dimensions of this container. So if you were to draw a picture to kind of visualize what's happening, what I'm told is that the width is 5 feet less than the length, right? So the width is 5 feet less than the length, so the width will be L minus 5. We'll do capital L so it doesn't get confused. L minus 5. And then I'm told the height is going to be 3 feet less than twice the length. So that means I'm going to multiply the length by 3, and then I'm subtract 3 from that. It's 3L minus 5. So in this case, or minus 3, sorry. So it's going to be, we'll do it right here, 3 times the width is slightly less than, So a height is 3 times L, or 3L, oh, sorry, 2L, sorry, I'm going all over this. 2L minus 3, there we go. The height is 3 less than twice the length. So if the length is L, the width is L minus 5, the height is 2L minus 3. 3 less than twice the length. Everyone with me? Are we good? So I'm told the volume is 154.
Now 3 o'clock. If you are not with a coach, director, sponsor, or in tutorials with a teacher, you must now exit the building.
All right, so the equation for this problem is your volume equals length times width times height. So 154 equals 2L minus 3 times L minus 5. This L, I'm just going to distribute it in. I have 2L minus 3 times L squared minus 5L. And then I'm gonna multiply them out. So 2L times L squared, that's gonna be 2L cubed. 2L times negative 5L is negative 10L. Distribute the negative 3, negative 3L squared, and plus 15L. I'm going to subtract the 154 over, because remember, anytime you're solving for a variable, you always want the other side to be equal to 0. It's easier to solve for 0 than it is to solve for any number. So I'm going to have 0 equals 2L cubed minus 3L squared, and negative 10L and 15L is plus 5L minus 150. 10L squared? Oh, it is 10L. Thank you. I would have saved a lot of time. Okay. So it's 2L cubed minus 13L squared plus 15L minus 154. Thank you. Okay. So from here, it's all my coefficients are integers. So I know that my possible rational zeros are going to be factors of the constant 154 over factors of your leading coefficient. So in this case, it's going to be factors of 54, which will be, you have 1, you have 2, 3 doesn't work, 4 works, 5 doesn't work, 6 doesn't work, 7 works, 8, I don't think 4 doesn't work? Oh, 4 doesn't work, you're right. Wait, it's yeah. 7 works, 8 is not going to work, 11 is the next one that works, 11, 14, do you have what's the rest of them? 22, 77, 150. All over factors of the leading coefficient, which is 1 and 2. So basically, all your possible zeros are all your numbers on the top, or all the numbers divided by 2. Right? So I'm not going to bother with the fractions at first. I'm always going to deal with the whole numbers first. So I'm going to set up my synthetic division. My coefficients are 2, negative 13, 15, and negative 154. And I'm going to start really with 7. So you guys remember, if it is a word problem, so context matters here. So I'm told here that my width is L minus 5, and my length is L. So that means your length, or your L that we're solving for, cannot be a negative number right away. Because if it is, if a negative number does end up factoring here and working, it's useless for me anyway, because I need to figure out dimensions of a box. It wouldn't work for me anyway. So right away, you can cancel out all the negatives. They're not going to work. And even if they did work, it's useless for me. It's not going to help me solve this problem. Also, I can cross out 1 and 2, because if I plugged in 1 and 2 into the width, I'll get a negative width. That doesn't make any sense. So same thing, it's not going to be useful for me. I'm going to throw that out. So I'm going to start with 7. 7 is the first one that actually makes sense in the context of this problem. So that's going to be the first possible factor I'm going to try. Does that make sense? Are we okay with that, guys? So drop down to 2. 7 times 2 is 14, plus negative 13 is 1. 7 times 1 is 7, plus 15 is 22. And 7 times 22, I think that's actually 154, right? Yeah, it is. And you get 0. So right away, 7 works. That tells me my L is going to be 7. You have your answer. So what I can do is go back to my problem, and we'll have 2L minus 3 for my height. And that's going to be 14 minus 3, or 11. My length is just 7. My width is going to be 2. So if I write it a little nicely, or a little nice, my height is 11. My length is 7. My width is 2. And that's going to be your answer. Any questions here? Are we okay? All right, let's keep going. 28. What is the maximum number of roots the polynomial can have? So remember, the total number of roots has to equal or cannot be greater than the degree of the whole polynomial. So roots, when I say maximum number of roots, that means how many distinct roots can you have? So in this case, the most you can have is 5. You cannot have more than 5, because if you did have more than 5, you have more zeros than you have degrees, and that doesn't make sense. The degrees has to equal the number of zeros that you have. So that's why here the maximum number of roots is going to be 5. Number 33, write a polynomial function with integer coefficients and minimal degree with zeros of -2 and 5 minus root 2. So for this one, since I'm told I have integer coefficients, that tells me that every single root theorem is going to work. The irrational, the irrational, and the complex, all 3 of them are going to work. So that means everything gets a pair. Well, every irrational and complex number gets a pair. So if I'm told that -2 and 5 minus root 2 are zeros, that means 5 plus root 2 has to be a 0 as well. So that means when I put these into my factored form of x plus 2 times x minus 5 minus root 2 and x minus 5 plus root 2. Like if you want to do this, like write out your factored form a little properly, I guess you'd say. This is what you get. But this part right here, you can multiply those 2 parts together a lot easier by just setting x equal to your conjugate pair. Right, instead of multiplying out these 2 trinomials, what I can do instead is I can set x equal to my complex conjugate pair, and then I want to isolate that plus or minus. So subtract the 5 over. And then square both sides. And what you get is x squared minus 10x plus 25 equals 2. Subtract the 2 over, x squared minus 10x plus 23. And that x squared minus 10x plus 23 is what you get when you multiply these 2 together. Right? Just a lot easier way to solve for your quadratic that gives you those roots rather than, multiplying the whole trinomial out. Are you good with that? Make sense? All right. And I still have this x plus 2 to do. So from here, just multiply them out, distribute the x in, you get x cubed minus 10x squared plus 23x. Distribute the 2, 2x squared minus 20x plus 46. Add like terms, x cubed, negative 10x squared, and 2x squared is negative 8x squared. 23 negative 20 is a positive 3x plus 46. And that's going to be your answer for 33. Any questions here? Are we okay? Good. Great. So 34, what is the minimum degree of a polynomial with these zeros? And this problem, I think, also says that you have rational coefficients. That is important because your coefficient will tell you what gets a pair and what doesn't. So the polynomial has rational coefficients. That part's important. And now what I'm going to do, because I'm told I want a minimum degree. So when we say the word minimum degree, what that means is we want everything to have a multiplicity of 1 and do not add any zeros in unless you absolutely have to. Like for instance, if you have a pair, you have to add a pair, add that in, but don't just start adding in random zeros. So make sure everything has a multiplicity of 1 or make sure nothing repeats and don't add any zeros. So what I'm going to do is I'm going to go down each factor and see, well, what's going to get a pair and have I had that pair before? So I have a 3. That doesn't get a pair. I can leave it alone. Then I have root 5. Okay. Kind of ugly, but it makes it easier like this. So 3, that doesn't get a pair, but root 5 does. It gets a pair of negative root 5. Negative 3 plus root 7, that gets a pair of negative 3 minus root 7. 2 plus root 6, that's going to get a pair of 2 minus root 6. Then I have 1 minus the square root of 9. So remember, for something to get a pair, the square root needs to be in a form where it cannot be reduced down. So the square root of 9, it can be reduced, or in other words, it's not an irrational number. And that's important for pairs. You only get a pair if the square root is an irrational number. The square root of 9 is not irrational because it's just 3. And 1 minus 3 is just negative 2. So it does not get a pair, it's just negative 2. Then I have 3 minus root 7. Well, that's the same as 3 plus root 7. Then 2 minus root 6 is the same as 2 plus root 6. But I already have that 2 minus root 6 written down before. I don't want anything that repeats, so I'm just going to cross out one. Doesn't matter which one, just cross one of them out. And once you have all your zeros, or all your possible zeros written out, I'm just going to count them all out. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the minimum degree is going to be 10. So I don't want anything to repeat. So everything has to have a multiplicity of 1. And 1 minus root 9 does not get a pair since root 9 is not irrational. Any questions about that? Make sense? Did I? Okay. Well, got an extra one now. It's an easy problem. It's like it was one from the notes. I thought it was a good problem to go over again. Are we good here? All right, 35. This one is odd. So circle all the following roots that satisfy the irrational root theorem. So when we say that satisfy the irrational root theorem, what that means is basically if the irrational root theorem is working, which one's going to get a pair, right? So in this case, root 5, that is going to get a pair because you get negative root 5. 3 minus root 2 will get a pair. 1 minus root 4 will not get a pair since the square root of 4 can be reduced down to 2. So it doesn't get a pair. Negative 7 minus root 3 will get a pair. Root 2 minus 9, this will get a pair. 2 plus the cube root of 3 will not get a pair. It's a cube root, not a square root. That gets a pair. 6 minus square root of 2 gets a pair. And 2 over 3 minus root 5 over 8 also gets a pair. Any questions about why any of those are pairs or why some of them don't get pairs? Are we good with that? Yes. All right, let's keep going. This one said, people asking about it. So f of x equals x to the 4th plus ax cubed plus the coefficient of 2b minus 1 plus the cube root of 4 times x squared minus 18x plus 150 has a root of 6 minus the square root of 11, and the value of a is an integer. Find a value of b that guarantees 6 plus root 11 is also a root of f of x. So the only thing that will guarantee that 6 plus the square root of 11 is going to be a root of this f of x polynomial is if all your coefficients are rational numbers, right? Because that makes it so the irrational root theorem works. So you need all your coefficients to either be integers or, really irrational numbers. So that means I need this 2b minus 1 plus the cube root of 4. I need this to equal some rational number. That's what I need. I need this to be a rational number. So what I'm going to do is I'm going to solve for b that makes it a rational number. And honestly, the easiest way to do that is just to say that, well, what happens if I take 2b and I make it equal negative cube root of 4? Because what's stopping this whole thing right here from becoming a rational number is this cube root of 4. Cube root of 4 is an irrational number. So to make this rational, the easiest way is to get rid of that cube root of 4. And the easiest way to get rid of that cube root of 4 is just to make 2b equal the negative cube root of 4. Say it that way, right? Because if it equals negative cube root of 4, Well, it's going to cancel out that positive cube root of 4, and you end up with just -1. That's a rational number. So in this case, b is going to be negative cube root of 4 all over 2. Honestly, there's like an infinite amount of answers you can have. This is probably the easiest one to go with. That's the one I would. Does that make sense, guys? Are you okay with that? Good. Well, the -1, what happens here is you plug in this b value into here. What you get is 2 times your b of negative cube root of 4 over 2, right? -1 plus, right? If I took this b value and plugged into here, that's what I get, right? So when I do this here, these cancel out, and you're left with negative cube root of 4 -1 plus the cube root of 4. You're just left with number 1. So the point is really just when you plug this b value back into the original, what happens is that these cancel each other out, and you're left with negative x squared. So the reason we're doing that is because the cube root of 4 is what's stopping that parentheses to be a rational number, right? You see that? So the easiest way to make it into a rational number is to get rid of the part that makes it irrational. So you just make it, make it whatever cancels it out, right? Does that kind of make sense what I'm saying, Dennis? A little? Is everyone else okay though? I can explain to you after this whole thing's done. We good? All right, the last problem is this long one that we did today. So we're given this f of x. We're told that r and t inside that polynomial are integers. That's important because if r and t are integers, that means everything in this polynomial is an integer. That means all 3 theorems work. They're rational, irrational, and complex. And I'm told f of x contains these 3 zeros. And what I want to do is I want to find, well, what's r, what's t, and what's the rest of these zeros. So right away, I can say that, well, 2 of my missing zeros has to be 3 plus I, and 2 minus root 3. Right? All my coefficients are integers, and if that happens, that means all your square roots get pairs and all your complex numbers get pairs. So I can pair them up right away, and I already found 2 of my missing zeros. Right? And also, something else that might be a little different than what was on the notes, but can be a little tricky here, is that this f of x, if I look at it, I have a GCF of x. So what I want to do here for f of x is I want to factor out an x to make my life a little easier, make the polynomial a smaller degree and easier to work with. If I factor out that x, I'm left with x to the 6th minus 8x to the 5th plus 12x to the 4th plus rx cubed minus tx squared plus 158x minus 30. So I can factor out that x. And what this x tells me is I also have another missing zero of just 0, right? The x by itself is a factor, and that factor or the root is 0. So that's a third missing zero I just got right away. Everyone with me? So what I want to do now is I want to start working with this part right here. This part underlined in blue, that's what I want to start working with, because that part right here has an r and a t. The x, I factored it out. I don't have to really deal with it anymore. It's not that important. But I do know that in this underlined blue part, 3 plus I, 2 minus root 3, 3 minus I, 2 plus root 3, and 1 are all factors. So what I can do is I can just multiply them all together. Right? So I have x minus 1. And then that 3 minus I can set x equal to 3 plus or minus I. Right, I'm doing what I did before. I'm going to create my quadratic that gives me those roots. So subtract the 3 over and square both sides. Get x squared minus 6x plus 9 equals -1. Or x squared minus 6x plus 10 is a quadratic that gives me the roots of 3 plus or minus 5. Then I'll do the same thing with 2 plus or minus root 3. Subtract the 2 over. square both sides. I get x squared minus 4x plus 4 equals 3. Or I can multiply that with x squared minus 4x plus 1. I can multiply these two together with this x minus 1. Is everyone with me so far? Are we okay? So what I did so far is I factored out an x from the beginning right here, and I'm dealing with that 6-degree polynomial in the parentheses. Inside that 6-degree polynomial, I know 5 of its roots, 3 plus or minus I, 2 plus or minus root 3, and 1. And what I'm doing now is I'm multiplying them all together to figure out, well, what's my last factor going to be, right? If you guys remember from class today and also from the first day of module 8, since all my coefficients are integers, that means the rational root theorem works. And that's important because if I multiply all my constant terms, that means I should end up with the constant from the beginning, right? The polynomial in the parentheses from the very beginning, that was that negative 30. I get that negative 30 by multiplying all the constants in my factored form right here in the bottom, right? Negative 1 times 10 times 1. That gives me negative 10. So negative 10 times what will give me negative 30? That's a positive. Right, if I multiply negative 1 with 10 with 1 and 3, that gives me the negative 30 that I have right here. Any questions about that? We good? All right. So from there, I found all my missing zeros, right? My last missing zero is negative 3 from the x plus 3. But the only thing I'm missing now is that s and t, the r and t. So I need to multiply these all out together to figure out, well, what is my r and my t going to be? So this is going to be a pain, but we have to do it. So I'm going to multiply these two together first. So distribute the x. I have x cubed minus 6x squared plus 10x minus x squared plus 6x minus 10. If I multiply these two together, I'll distribute the x and then the 3n. I get x cubed minus 4x squared plus x plus 3x squared minus 12x plus 3. Where I'm kind of working on both sides at the same time. Trying to do these two together and these two together. This is to make it a little faster. Then I can add like terms of x cubed, negative 6x squared and x squared is negative 7x squared. 10x and 6x is 16x minus 10. And the second one, I have x cubed, negative 4x squared and 3x squared is negative x squared. X and negative 12x is negative 11x plus 3. Everyone with me so far? Any questions? No? All right, in this case, I'm not going to distribute them. I'm just going to do the box method. X cubed, negative 7x squared, 16x, and negative 10. All with another x cubed, negative x squared, negative 11x, and 3. So x to the 6th, negative 7x to the 5th, positive 16, x to the 4th, negative 10x cubed. Then negative x to the 5th, negative 7x to the, or positive 7x to the 4th, negative 16x cubed, and 10x squared. Then negative 11x to the 4th, 77x cubed. What's 16 times what? Not good. 176. All right, 16 times 10 is 160 or 176. X squared, and then 110x. 3x cubed, negative 21x squared. That's 48. x and negative 30. Are we good so far? And then we're gonna start adding like terms. So I'm gonna start with a 6-degree polynomial. I have x to the 6 right there. Then I'm looking at 5th-degree polynomials. I have negative 7x to the 5th and negative x to the 5th. That's negative 8x to the 5th. I don't have anything else, I don't think. I don't. Then my 4th-degree polynomials right here in this diagonal. That is 5, 12, x to the 4th. Then my cubes, that's 80 and negative 26. That's 44, right? Or 54. 54x cubed, right? 80 minus 24. 54, yeah. 54x cubed. Then my squares, I have negative 11x squared, negative 187. Then 158x minus 6. Is everyone with me? I know it's a lot of work, but we're finally done, right? We got my polynomial, what it should be. So if I take this and I compare it to the original, I have pretty much the same exact thing, right? Except I know what my missing R and T is going to be. That's for the 4th degree and the 3rd degree. So the 4th degree is 4th or 3rd? Oh, sorry, we're using the 6th one. So it's the 3rd and the 2nd one we're worried about. So the 3rd degree is 54. So R is 54. And T is a positive 187. The reason it's a positive 187 is because this question decided to be, extra tricky, and it's negative T here. So because of that negative T, it's positive 187.
We also factored out.
You could if you want to. The thing is here, what I'm doing is x to the 6 right here. So then you see x to the 6 right here. This polynomial is the exact same one as this one right here. So I basically what I did is I factored out the x and said, I got the 0 from it. I don't care for it anymore. I'm gonna deal with the 6-degree polynomial. But if you wanted to, you could factor in that x if you wanted to. All it's gonna do is rate the degree of everything by 1, and you just end up with the original, but it doesn't really matter. And then my missing zeros. It was a 0, 3 plus I, 2 minus root 3, and that negative 5 that we got from the constants. A lot of work. Any questions about any of that? Are we good? All right, I'm gonna stop the recording.